Good afternoon and welcome to NASA's Kennedy Space Center. I'm Daryl Nail. Appreciate you joining us. We're here ahead of the launch of NASA's Interstellar Mapping and Acceleration Probe, or IMAP, targeted for 7:32 a.m. Eastern, a launch that is, on Tuesday, September 23rd, on a SpaceX Falcon 9 rocket from Pad 39A. IMAP will study how the sun shapes the space around us with two rideshare missions on board. NASA's Carruthers Geocorona Observatory imaging Earth's outer atmosphere, and NOAA's SWIFO-L1 providing early warnings of solar storms. Together, these missions will strengthen our understanding of space weather and its effects on Earth and our explorers. And to talk about that and answer your questions for the media today, joining me here is a fine panel of folks, starting with Dr. Nikki Fox, our Associate Administrator for Science Mission Directorate at NASA headquarters. To her left, Brad Williams, IMAP Program Executive, also at NASA headquarters. We have Irene Parker, Deputy Assistant Administrator with NOAA NESDIS. Dr. Denton Gibson, Launch Director for NASA Launch Services Program. Juliana Scheiman is the Director for NASA Science Missions at SpaceX. And Arlena Moses, our Launch Weather Officer for today and the launch from the U.S. Space Force. Now, today's briefing will focus on the mission readiness and the launch. Questions about the scientific details will be answered at another press conference coming up at 3:45 p.m. Eastern, and will feature mission science teams from NASA, NOAA, Princeton University, and the University of Illinois. So we'll begin with remarks from our panelists and then take your questions here in the room and on the phone line. So Dr. Fox, why don't you kick us off?
Thank you so much, Daryl, and thank you for joining us for this very, very exciting run-up to this incredible mission launch. The Apollo era certainly taught us that the further humanity is from Earth, the more dependent we are on science to protect and to sustain life on other planets. And we certainly learned that in between the Apollo 16 and 17 missions, when the astronauts narrowly missed catastrophe when one of the most powerful radiation storms recorded since the Carrington event of 1859 occurred in August of 1972. Had the astronauts been in orbit or, in fact, on the moon's surface, they could have experienced dangerous levels of high radiation sparked by the historically enormous solar flares bursting from the sun at unprecedented speeds. I'll say, if you haven't seen it, it's called the Seahorse Flare, and I seriously do recommend that you Google it. It's a beautiful flare. The storm, not only was it beautiful, but it was so fast that the solar radiation itself was so intense that the impacts didn't just remain in space. The coronal mass ejection, or CME as we call it, traveled from the sun to Earth in a record-breaking 15 hours, and that's sort of compared to the more usual 2 to 3 days. And it still holds the record to this day. The United States experienced radio blackouts, significant power grid disturbances, satellite damage, and those as far south as Texas saw spectacular aurora. It also caused magnetic disturbances, which triggered the accidental detonation of U.S. naval sea mines from the Vietnam War. At that time, there was no way to really predict when a solar storm would begin to brew. Now, NASA is leading the United States to be a space weather-ready nation. And on Tuesday, NASA, alongside 27 national and international partners, will launch the Interstellar Mapping and Acceleration Probe, as we lovingly refer to IMAP. IMAP is a mission of firsts. It will be the most advanced spacecraft dedicated to mapping the heliosphere's outer boundary, which is a key piece in the heliophysics puzzle about the sun's influence on our solar system. To do this, IMAP will spin every 15 seconds to measure the invisible plasma around it, and it will do that using a comprehensive suite of 10 revolutionary instruments. From its strategic position 1 million miles upstream from the Earth, IMAP will provide warnings, and they will be provided, of course, for Artemis 2 and Artemis 3 of incoming radiation. It will provide advance notice for astronauts and for those on Earth using the IMAP Active Link for Real-Time, or iAlert, system. Radiation exposure is a real threat to our astronauts traveling to the moon and beyond. Humanity has only ever existed inside our protective magnetosphere, and as we travel beyond that protective shield, whether it be to the moon or to Mars, the actionable information from missions like IMAP will keep our astronauts safe. Through NASA's Moon to Mars program and NASA's Moon to Mars Space Weather Moon to Mars Space Weather Analysis Office. That's a big mouthful. We can implement the iAlert system for upcoming Artemis missions on our sort of lunar proving ground before we actually send humans to Mars, which is really, really significant. NASA science supports the agency's core exploration safety imperatives by enabling research and instrumentation relevant to ensuring that astronauts can protect themselves in time when we know a space weather event is coming. Riding alongside IMAP is a mission of opportunity, NASA's Carruthers Geocorona Observatory, and it totally complements IMAP's data by helping us to understand the space weather near Earth and how it impacts a sort of very little studied atmospheric region called the exosphere. The exosphere is basically our last frontier before you hit deep space. The only time we've been able to image it before was using a camera that flew on the Apollo 16 mission, and that's the best image we have to date. With Carruthers, we'll be able to stare constantly and look at how this very, very final barrier between outer space and us actually responds to space weather. So it's a really, really great partnership. The exosphere's response to space weather shapes how the storms actually impact our technology, including communication signals in the upper atmosphere and power lines on the ground. Now, you're going to hear a lot more about IMAP, about Carruthers, and about NOAA's SWIFO L1 mission from Brad and from Irene, and then again, as Darryl said, during the science briefing. So I will end with a thought that today the Apollo-era flare serves as a reminder of the threat that radiation exposure has to technology and to astronauts in space. The safety of the environment in which our astronauts are robotic explorers and the infrastructure that will be deployed is critically dependent on dynamic space weather conditions which affect us daily here on Earth. But obviously much safer and much lower levels for us here on Earth than out at the moon. As the United States prepares to send humans back to the moon and onward to Mars with the Artemis program, NASA science is actively providing the ultimate interplanetary survival guide to help support humanity's epic journey along the way. IMAP, Carruthers, and NOAA SWIFO L1 build upon our fleet of missions studying the sun, including Parker Solar Probe, and soon we will add ESCAPADE, which launches later this fall. All of these missions together support and enhance the existing space weather prediction capabilities in coordination with NOAA throughout our solar system in near real time for the benefit of all. So I want to say thank you to our mission partners, to SpaceX, and most importantly to the IMAP, Carruthers, and SWIFO L1 teams. Go NASA, go NOAA, go Falcon. And over to you.
All right. And good afternoon. And thank you all for being here and everybody tuned in. It really is an honor to be here before you today following a successful conclusion of our launch readiness review. For all of those who have worked tirelessly on the IMAP mission and its partners, it's truly a momentous occasion today. So I just want to take a moment to specifically acknowledge and celebrate the incredible work of the teams that made this possible. The IMAP mission is a testament to the power of cooperation and collaboration that Nikki mentioned. So just reemphasizing 27 domestic and international partners on the IMAP mission under the leadership of our PI, Dr. Dave McComas from Princeton University, and also our partners from Johns Hopkins University Applied Physics Laboratory. The team's made up of a group of scientists, engineers, mission partners, whose dedication has brought us this special moment, ready to embark on a journey that will teach us more about the heliosphere and enable crucial new space weather measurements alongside our partners at NOAA. For all of their hard work, I just want to thank them, all the team that's out there watching and continuing work today. So the teams from all three of those missions, SpaceX, APL, NASA Goddard, BAE Systems, University of California, Berkeley, and many other partner organizations, they've spent months meticulously planning these integrated operations down here at the launch site that are unique and essential for a rideshare mission like this. In the last few weeks, these teams successfully executed all of those well-coordinated activities that have led us to the launch pad today. I would be amiss if I didn't didn't highlight how instrumental the NASA Launch Services Program has been and Denton's team, how truly instrumental in integrating these three missions together, demonstrating our agency's ability to innovate and find new ways to accomplish our scientific goals. By launching 3 spacecraft on one launch, we've maximized efficiency and achieved cost savings. The synergies across these 3 missions really are remarkable. IMAP will be our celestial cartographer, providing a comprehensive map of the heliosphere's protective boundary and the energetic particles that threaten our space assets and human explorers. In parallel, the SWIFO-L1 mission will deliver critical space weather directly to NOAA, enhancing our nation's forecasting capabilities. And finally, the Crothers Geocorona Observatory, led by Laura Waldrop at the University of Illinois, will provide a unique perspective, looking back at Earth from L1 to study the planet's geocorona and better understand how our atmosphere interacts with the space environment. Over the last week, the ride shares were integrated onto the ESPA ring, IMAP was integrated onto the top of that stack, and they were all encapsulated into the fairing. They were then transported to SpaceX Pad 39A, and that encapsulated assembly with all 3 spacecraft has been mated to our SpaceX Falcon 9 rocket. And at that point, they have completed aliveness checks, and we're happy to share that all the spacecraft are healthy and ready for launch. And with that, I will pass it over to Irene Parker.
Good afternoon. I'm thrilled to be speaking with all of you today to see the excitement ahead of the launch. Just hearing Dr. Nikki Fox talk about Space Weather Ready Nation, I would like to say that's just going to be an amazing feat, and all of these 3 missions are really going to be supporting that. So with that, space weather has an impact on our daily lives, from GPS we use to navigate around the globe, and even to the food we eat, grown by farmers relying on precision agriculture. Forecasting space weather events that can disrupt these technologies is critical to protecting our country's economic vitality and national security. SWIFO-L1 is the first fully dedicated NOAA observatory designed specifically for continuous operational space weather observations. The satellite will be our first line of defense and serve as an early warning beacon for the potentially devastating effects of space weather. SWIFO will orbit in the sun from the Lagrange Point 1, a position in deep space about 1 million miles between Earth and Sun. The positioning allows for continuous, unobstructed observation of the Sun's corona without interference from the Earth. The 24/7 data from SWIFO-L1 will give the operators of NOAA's Space Weather Prediction Center the critical lead time to make precautionary actions that protect vital infrastructure, economic interests, and national security on Earth and in space. The 4 instruments on board SWIFO-L1 will collect real-time data and measurements of solar wind, thermal plasma, and the sun's magnetic field. These observations are key for the accuracy of forecasts and warnings from NOAA's Space Weather Prediction Center. SWIFO-L1 will feature NOAA's second operational compact coronagraph, otherwise known as SEACOR, which will help detect solar coronal mass ejections, the most hazardous form of space weather. Our first SEACOR launched aboard GOES-19 in June of 2024 and is currently operational from our geostationary orbit. I must stress that SWIFO is a joint program between NOAA and NASA, and both of us have an important and complementary responsibilities in the development, testing, launch, and operation of the mission. NOAA is the program owner that determines the requirements, provides funds, and manages the program, operations, and data products and dissemination to the users. NASA and our commercial partners develop, build, and test the instruments and spacecraft on NOAA's behalf and the NOAA specifications. In Maryland, the NASA Goddard Space Flight Center provides acquisition, engineering, and project management support to NOAA for developing the mission. NASA's Launch Services Program, based at Kennedy Space Flight Center in Florida, manages the launch. Overall, SWIFO is a part of our NOAA's larger plan, the next step, which is a program called Space Weather Next, which is designed to provide long-term continuity and enhance space weather monitoring capabilities well into the future, ensuring our nation's technological infrastructure remains protected. NOAA is working closely with Congress and the administration to fund the Space Weather Next program, which launches of 2 core observatories at Lagrange Point 1 targeted for 2029 and 2032, ensuring continuities of these critical services. With that, I'll pass it over to Dr. Denton Gibson from NASA LSP.
Thank you. As always, I am excited and humbled to be sitting here representing the NASA Launch Services Program. a program since 1998 has been partnering with commercial industry to launch over 100 of NASA science missions all throughout the solar system. And just kind of getting ready for this mission, we were just thinking back, our first mission with SpaceX was the 20th flight, and now IMAP will likely be the 550th flight, which is a huge testament to what SpaceX has accomplished, and another step in this partnership that we forged with them. And this will be our 13th mission with SpaceX, so we're really looking forward to that. And I will just take a minute to recognize the organizations that really came together. This Space Launch Delta, SpaceX, NOAA, and NASA to really forge a great partnership to have another excellent mission. So you've heard there's 3 spacecraft on this mission. So it's almost as if our mission integration team had to work 3 missions simultaneously. And it has been going very well. Our team has been busy over the last couple of weeks. Last week we had our mission dress rehearsal, which was a simulated countdown where we really exercised the team to get them very prepared to be on console, to be able to handle anything. We also had the FRR last week, which went well, and we were ready to proceed forward with the rest of the integration. And we also, on Friday, we also had the Space Launch Delta 45 LRR, which also the Space Launch Delta 45 leadership gave their go to proceed into count. And earlier today, just about an hour and a half ago, roughly, we concluded the joint NASA SpaceX LRR, where all of leadership gave the go to step into launch count early Tuesday morning. And with that, I would like to play a video here. We have a video here to show you some of the integration work that has been done. So here, as you heard mentioned, IMAP arrived here at Astrotech in Titusville around May, second week of May. And then also Swift-Hole L1 and Carruthers arrived mid-July. And as we mentioned, the payload adapter mate happened early September, where all 3 spacecraft were made and you had a good shot there. And the encapsulated assembly, which you're looking at right there in the photos, that occurred September 16th. And then the transport to the launch pad, and that's what you're looking at right there, to the hangar near launch pad, is looking at transport. That occurred September 17th. And you get some good shots in front of the VAB. And this is just an example. This is not the actual footage of our launch vehicle, but this is an example of what it looks like. Rollout from the hangar at 39A to the launch pad is occurring right now. So hopefully by the end of this, we may or may not have a good shot as they work through that. So there you go. So as we, if you're looking at everything that's going on, we are in good shape. We are early Tuesday morning, roughly about 30 to 40 minutes ahead of our T0. I will pull the NASA team to step into propellant loading and launch. And all goes well. The propellant tanks on the Falcon 9 will be loaded with densified propellants, and the team will be stepping into looking at a T0 at 7:32 a.m. Tuesday morning. And just to summarize, the Falcon 9 is ready. The IMAP, Swift-Hole, Carruthers teams are ready, and the integrated team is ready and excited to step into launch count. With that, I would like to turn it over to my partner in crime, who I've worked with since like 2012, Juliana Scheinman, the Director of NASA Science Missions.
Thank you, Denton. Thank you, Dr. Gibson. I'm super excited to be here today to talk about our next science mission. Everyone at SpaceX is incredibly proud to support missions like this. As you heard the team talk about, IMAP, Swift-Hole, Carruthers, these are all space weather missions. And space weather, as you heard Dr. Fox talk about, is incredibly important for all of our missions that we do at SpaceX. For launching Falcon, like launching IMAP, for human spaceflight missions, and for operating our satellite constellation. The space weather data is critical for mission success, and it's critical for future human missions to Mars. So thank you, NASA and NOAA, for doing amazing missions like this that help us build the next generation and the next missions. As you've heard me speak about in the past, one of the reasons I came to SpaceX was because I wanted to help enable greater scientific exploration. And the way we do that at SpaceX is by lowering the cost of access to space. And we have been very busy doing just that for NASA and for NOAA over the past few years. In fact, as you heard Denton mention, IMAP is our 13th mission for the NASA Launch Services Program. It is also our 7th mission in less than 2 years for the NASA Launch Services Program. We've been busy. Earlier this year, we launched SphereX with 4 Punch payloads. In July, we launched the Tracers mission, which flew with a total of 5 NASA spacecraft. And coming up here, we're launching IMAP, SWIFO, L1, and Carruthers. So actually, this year alone, we will launch 16 critical NASA science payloads when you look at, when you add in the commercial lunar payload services missions and rideshare missions that fly on our transporter program. So we are big team science and very proud to support those critical science missions. Also, when I think about the next generation of vehicles, I'm super excited for how Starship will enable another level of science. Starship, with its large payload volume and excess performance, we have the ability to support never-before scientific missions, like incredibly large telescopes or interstellar missions that don't need to measure mass down to the gram. So, but focusing on Tuesday morning, very excited to launch IMAP, SWIFO L1, and Carruthers. And I want to thank NASA and NOAA for their continued confidence and partnership. And I will pass it over to Arlena for the weather, who is wearing her sun earrings, so I know we're going to hear good news.
Thank you very much. Yes, I thought the sun earrings would be appropriate given the mission that we're working on. And also, while we're not looking from a space weather perspective, as a launch weather officer, we're looking from a terrestrial weather perspective. Sun still plays a big part of that as well. So as we go into Tuesday morning, if you've been here locally on the Space Coast, you know we've had a bit of a dry spell after our very wet late summer, early fall time frame. It's felt just really nice kind of getting into the Florida fall time frame. Unfortunately, that's going to change a little bit as we start our week here over the next couple days. We're going to have an upper level system that comes through, and that's going to bring back a little bit more moisture and also kind of ruffle up the atmosphere just a little bit. That'll play a part as we go late Monday into the first part of Tuesday. So if we want to take a look here at the forecast for our primary launch day, we're going to be overall looking at a POV, or probability of violation. That's a probability of seeing any of those launch weather concerns. There are 10 of them that are possible that we look at, of 25%, so 25%. Or if you want to look at it in the reverse, that is a go of 75%. And our main concerns for our primary launch day are going to be something called the thick cloud layer rule. So that's looking at types of clouds that are not like thunderstorms or cumulus clouds, which those are the big puffy cotton ball clouds. Those are looking at the kind of flat clouds you sometimes see that roll in during like wintertime storms, no matter where you are here across the northern hemisphere. And winds are going to be relatively light, so not expecting too much of a concern with that. Now, as we go into our backup day, looking at the forecast for our backup day, that little upper level disturbance we have starts to move by, and we get a little bit drier conditions moving in. So looking at our forecast numbers for the backup day, we're overall looking at a probability of violation of 10%, or looking at GO of 90%. So those numbers come down quite a bit, especially given the time of morning that we're going to be launching, usually not the peak of what we see for our shower and thunderstorm activity here along the Space Coast for Florida. So there are a couple things that we're going to be monitoring for our launch coming up here, but overall I think things are tracking good for weather. Back to you, Dale.
All right, thank you all. To our panelists for those opening remarks. Let's get to the questions now. We'll start off in the room. We do have questions on the phone, so if you want to punch the key to let us know you have a question, we'll get to your question. But again, we'll start in the room, wait for the person with the mic to come over, and then state your name and your media affiliation and your question. And let's start with one question at a time. And so our first question at the front of the room, Ken?
Hi, thank you. Ken Kramer, Space Up Close. Good luck to you all. This really exciting mission, and wishing you all good luck. Nikki, I have a question for you. Since you mentioned Project Artemis, there was some really great news about Viper on Friday night. It was canceled, and now it sounds like you're reviving it. There were very scant details. We'd like to hear, how did it come about? And what can we expect? Will it launch in 2027? Thank you.
We're very excited about Viper. The actual sort of cancellation of the project at the time certainly did not reflect any lack of excitement about the science and the importance of actually going in and sampling for volatiles on the moon. Unfortunately, at that time, we did not have, a path forward for the Viper mission with a lander, and so we made the very difficult decision to actually sort of tie a bow on Viper. We continued it through the testing, and so it is completely safe. It is being stored very, very well, awaiting a launch vehicle, a landing. Wrong mission, a lander. We put out a couple of calls. We did some RFIs, put out a call for partnership, and we've sort of gone through a number of steps to find the right ride. It was actually solicited through a CLIPS payload call, so our CLIPS vendors were able to propose, and we were very excited about the successful proposal coming in from Blue Origin. So looking forward to being able to work with Blue and getting a successful end for Viper. The actual launch date itself, I think I'll refer you to Blue to get more details on that. But we're very excited about this partnership, and it really does highlight the importance of what we do at NASA Science for supporting the Moon to Mars and the Artemis programs.
Any other questions in the room? Yes, sir.
Hi, Manuel Masanti from Exploración Espacial. A question for Juliana. Can you describe a little bit more the sequence of deployments of the 3 probes? We know that the 3 of them are going to L1. Are they traveling together? How is the sequence going to work? Thank you.
Sure, I'm happy to explain that, and then feel free to chime in if you'd like to. So, again, very exciting that we have 3 payloads who all want to go to the same place, L1. And so the Falcon will lift off, the stages will separate. The second stage will perform 2 burns. After it's completed that second burn, the first payload that will be deployed is IMAP, and then we will deploy SWIFL L1, and then we will deploy Carruthers in that order. So IMAP first, SWIFL L1, and then Carruthers. And they're all deployed within about 10 minutes of each other, around an hour and a half after liftoff. And Denton, I don't know if you want to chime in times or any other.
Yeah, so IMAP will be deployed about an hour and 23 minutes after T0. And then SWIFL L1 will be deployed about 7 minutes after IMAP. And then Carruthers would be 6 minutes after SWIFL L1.
All right, let's go to the phones now for our next question. Will Robinson Smith with Spaceflight Now. Go ahead.
Hey, Daryl, thank you for the opportunity, and thanks to the panel. Apologize for the car noise in the background. Traveling to Houston ahead of the introduction of the astronaut class on Monday. Question to Nikki Fox. Of course, we're just a couple of weeks away from a potential government shutdown yet again. And there's a lot of uncertainty about where that leaves the NASA budget, and in particular the science budget, as to whether or not it will be subject to the proposed cuts from the Office of Management and Budget, or if there's a different operating level that you guys will use. So I guess, can you provide some clarity on if the government shuts down, what then, and especially what happens to the important science missions that are at risk of being unfunded or defunded in that scenario? Thank you.
Yeah, thanks so much for the question. As we do with every, possible government shutdown, we plan our sort of contingency operations. We always make sure that we're protecting life and property, and so therefore we make sure we take care of the missions that are already in space and operating. And clearly, obviously, we don't anticipate any slips to this launch. Looking down the table, and so these missions will be up in space. Obviously, making sure that they are, we are able to operate them and do all those really crucial things is really important. Even if, in the unlikely event that maybe the weather causes a slip, we would still have these prioritized. As of course, at this point, we would be risking damage to property if we didn't actually launch them. And so, I have no concerns about the care and feeding that will be given to these 3 missions. They're all very critical, and they're critical for many government priorities. And so we'll be certainly moving them through regardless of the shutdown.
And we'll stay on the phone bridge and go now to Stephen Clark with Ars Technica.
Hi, thanks for taking my question. Just if you could go down the line, please, for each mission, a total cost, and also, the earlier question about how they get deployed. Following up on that, how long does each mission take to get to L1 and enter operations? Thanks.
Yeah, so I can start with for IMAP and Carruthers. IMAP has a life cycle cost of $781.8 million. That includes development costs, launch vehicle costs, and operations costs for a 2-year prime science mission. The Carruthers Geo Corona Observatory has a life cycle cost of $97 million, including a 2-year prime science mission. And the total cost for NASA to launch these IMAP and secondary ride shares is $109.4 million.
All right. For SWIFO, our life cycle cost is $692 million, and that goes from concept phase all the way to operations and disposal. With that includes the SWIFO spacecraft, the 4 instruments, also the instrument, the first C-Core on GOES-U, along with our ground segment for operations. And we plan to be hopefully operational at L1 in April of 2026.
And I could just add back on IMAP. IMAP and Carruthers both arrive at L1 about 107 to 108 days after launch. Both are fully commissioned at that point and starting prime science.
All right, very good. And let's go back to the room now. And do we have any hands for questions? Ken?
Thanks for follow-up. Can you talk about coordinating these 3 missions together? Whoever can answer this question. There's got to be a lot of challenges and hurdles to that. You mentioned a little bit. Can you go into that in detail, please? And I don't know if from the beginning these 3 missions were planned to be together, or how did that happen? Thanks.
I'll take the last bit first, which was actually, IMAP was competed and selected in 2018. Was competed through 2017. During that time, the Heliophysics Division, under the leadership of Peg Luce, had this sort of wonderful idea of, we're going out to L1. What else could we travel with? Immediate partnership formed with NOAA to actually put their space weather follow-on L1 mission on the stack. And the proposal teams were asked, if it was the IMAP proposal teams were asked for permission to release their launch trajectories so that they could actually put together a plan. And then there was an actual call for ride shares for the IMAP mission that went out in 2018. The Carruthers, it was called GLIDE at the time, but the Carruthers Geo Corona Observatory was selected as one of those payloads. Another payload was selected as a technology demonstration, but unfortunately it did not get confirmed. So it was a very sort of well thought out plan to put these missions together on the stack. Denton?
Yeah, and as Nikki mentioned, once the decision was made to have all 3 on the stack, LSP starts working with the spacecraft to understand what their requirements are. Then once we put out proposal for launch services, and then once SpaceX was selected, then our team start working with SpaceX years in advance to ensure that all the requirements are met and we can fully integrate all 3 spacecraft to the Falcon 9. And that was years of planning and then months of execution.
All right, very good.
About SpaceX.
Yeah.
What did you have to do in particular to make this happen?
Sure. Yeah. In case you couldn't hear the question online, he asked what we could do in particular to make the mission happen. As Denton touched on, we had to look at all of the spacecraft requirements and make sure that we could support them on the mission. And so there's some very fun examples of requirements that we had to work through. My favorite one is that each spacecraft, IMAP, SWIFO, and Carruthers, all required their own T0 nitrogen purge, is what we call it, where we're actually purging nitrogen gas on contamination or moisture-sensitive instruments right up until liftoff. And so each one of those spacecraft have their own nitrogen requirements with their own pressures, their own flow rates, and so we had to build a unique system to have our sort of 3-headed beast of nitrogen purge for all those spacecraft. Another thing that comes to mind is, Dr. Fox mentioned this, but IMAP is a spin-stabilized mission. So at deploy, we have to spin the Falcon second stage 4 RPM, 24 degrees per second, like pretty fast to deploy the spacecraft. And so we had to make sure that when we're deploying IMAP at that rate, we haven't deployed SWIFT or Carruthers yet, that the entire integrated stack can support that maneuver. We can then slow down the spin and then deploy SWIFT and Carruthers. So it's a delicate ballet in space.
One of the cleanest environments required, right, for SpaceX and LSP on this mission.
Yes.
So, all right, thank you, Juliana. Let's go in the room to the gentleman in the back.
Hi, I'm Joel Achenbach, freelance, and I have a question for Dr. Fox. Following up the first question we heard, what is the status of all these other science missions that we've been told would be imperiled if the president's budget request were adopted? Can you give us some clarity of what's going to happen over the next several months? Have the leaders of these missions been told to prepare to shut down these operational spacecraft as a contingency in case the president's request is adopted or something like that is adopted? What do you tell the leaders of all these missions, whether they're Mars orbiters or New Horizons or Lunar Reconnaissance Observatory? What are you telling the people running those missions?
Yeah, thank you. That's a great question. So obviously all the information that we have in the President's Budget Technical Supplement was released on May 31st, and so I encourage you to look at that. There's a lot of great detail in there for the priorities under that budget cap. When that was released, we did, as we would always do, ask the missions for a plan of what it would take, what a shutdown looks like, if indeed that is the direction that we get. We are, of course, like every other agency, anticipating an appropriation to tell us exactly, what we will do moving forward. But of course, NASA as an agency always follows the law, works closely with the Office of Management and Budget and with our appropriations committees to ensure that what we do, of course, everything we do follows administration priorities. Everything we do is for the good of the nation, and so we just wait to find out what the level of resources we'll have to be able to continue to push all that forward.
All right, back to the phone bridge now. Jeff Faust with Space News. Go ahead.
Follow up with Joel's question for Nikki, a little bit more focused. If come the 1st of October, even if we have a CR, there are differences between the House and Senate funding levels for NASA science, which of course are very different from what is in the administration's proposal. Have you been given any direction on what level of funding to plan for during that time from when the CR kicks in, if there is a CR, until we get a final appropriations bill? Thank you.
To seeing the details of that CR, and whatever we are asked to do, we are ready to implement.
And just a reminder, we have all of our individuals for the panel here today are expert on the IMAP, SWIFT-OL1, and Carruthers mission. So if you have any questions about that, we certainly welcome those. And the gentleman, actually, let's go to one more on the phone line. I think Will Robinson-Smith is back in queue.
Yeah, thanks for allowing a follow-up, Daryl. To Irene Parker, you mentioned that obviously SWIFT-OL1 is the beginning of this next evolution in space weather tracking and warning systems under NOAA's purview. I wonder what are the next steps in getting to that marker of being able to launch in the late 2020s, in addition to working with Congress to secure the funding. How soon do you have to have it in hand before you can start actually building out these spacecraft? Thanks.
Okay, so the follow-on after SWIFT-OL1 is called SOLAR, and NOAA, through our NASA acquisition partner, have actually awarded the instrument and spacecraft contracts already for that with the support of the administration and Congress. So we're moving out on that. So right now we're on track for a 2029-2030 launch for SOLAR A.
All right, thank you. And on the line now, Kenneth Chang with the New York Times. Go ahead.
Hi, this is a question for Irene Parker. What's the status of Discover? Is SWIFT a replacement for that, or how does the instruments compare? And for Nikki Fox, what instruments on IMAP provide warning for astronauts that isn't on SWIFO? Thank you.
All right. For the status of Discover, as of July, we have not been able to be fully in communication with Discover. However, it is a secondary space weather mission, and we have our primary missions of ACE and SOHO that are providing that type of information, from solar winds to CME information. SWIFO, compared to Discover, will actually have higher capability and reduce the latency time for information coming from our L1 capability for like solar winds. And also it will also have the capability of a C-Core, which is going to be able to see the CMEs, which Discover currently cannot, but SOHO can. So we see that SWIFO as a great replacement, especially in the area of ensuring full 24/7 continuity post the wonderful missions of ACE and SOHO that they've been doing for I don't even know how many years beyond its lifetime. So we are looking forward to SWIFO launching.
And for your question about what IMAP has, I don't look at it so much as what IMAP has that SWIFO doesn't have. They're very different mission goals. So SWIFO has to provide space weather forecasting 24/7, and they do that with a set parameters that are tried and true, that we know how to feed into the models. What IMAP does is it is almost unfettered by that operational requirement. And so we can take these exquisite measurements that we will then sort of, see how they fit into the space weather puzzle. So we know what the next generation. So we're really helping the next generation of operational measurements by finding, is there this magic one that we haven't measured before? And now we're measuring it with IMAP, and it actually is kind of the game changer in the space weather forecasting. And so that's what we're looking for. We're always looking at ways to improve our space weather modeling. And with NASA Science, we're always pushing the boundaries, making first-of-a-kind measurements, and really putting just the exquisite models together that can then be transferred into the operational environment. So they just have very different, it's not about what one has and what one doesn't have. It's really about the focus of the missions. And so we continue to push the boundaries of science, and we do that. And we pass any of our knowledge, any of our breakthroughs go immediately to our very, very close partners, NOAA, as we want to enable better space weather forecasting for the nation.
And we have time for one more question in the room. And the gentleman here in the middle.
All right. If Timothy Milligan and Freelance, if for some odd reason IMAP is not able to deploy, would that stop the other two crafts from being deployed?
So if for some reason IMAP has an issue with deployment, the Falcon flight computer and mission software is designed to proceed with the mission. And so the intent will be that we would, if we fail to deploy IMAP, we would still subsequently deploy SWIFO and Carruthers.
All right, very good. Well, thank you to our panel for joining us and giving us all your insight. If you'd like to learn more about the 3 new space weather missions launching together, you can visit nasa.gov/sun. Also, if you have questions about that science, make sure you tune in to the Science News Conference at 3:45 p.m. Eastern Time. That's today. We'll have experts from NASA, NOAA, Princeton, and the University of Illinois. Finally, launch day, of course, is right around the corner. That's set for Tuesday, September 23rd. Our coverage on NASA Plus, YouTube, Amazon Prime, and more begins at 6:40 a.m. Eastern Time. We'll hope you tune in as IMAP and its rideshare companions head to space to expand our understanding of the sun and space weather. That concludes our briefing. Thank you for joining us.